Hello everyone, in this video we are going to discuss about Elgamal CryptoSystem. So this Elgamal is a public key crypto system. And this Elgamal CryptoSystem is based on Diffie-Hellman key exchange, or you can say it is based on discrete log problem which we have checked in Diffie-Hellman key exchange algorithm. So it is based on discrete log problem, and let's define the discrete log problem one more time. However, we have checked this discrete log problem when we discussed about Diffie-Hellman key exchange. So discrete log problem over ZP. What is discrete log problem over ZP? So this is discrete log problem over ZP. Let P is a prime. Let P be a prime. Then this ZP star is going to be ZP minus 0. This we all know. ZP star is going to be ZP minus 0, ZP minus 0, and this ZP star is a cyclic group. This we all know. Okay. Now let alpha be a generator. Let alpha be a generator, or you can say primitive element. Let alpha be a generator or primitive element of ZP star. Let alpha be a generator of or primitive element of ZP star such that beta is congruent to alpha to the power a mod p, where a lies between 0 to p minus 2. So now what is given here? Here given is alpha, beta, alpha and p, and what we have to do, we need to find a. This is a discrete log problem. We need to find a, and such that this a is the generator or primitive element of the group. If p is large, we say that if p is a large number, if this p is a large number, then discrete log problem over ZP star is very hard, because then time complexity is order of the prime number. So as much as large the p will be, that much hard the discrete log problem is going to be. To find this a is a discrete log problem, and this is a hard problem. So this Elgamal CryptoSystem is based on this discrete log problem. So if we take a large prime, then to find a will be difficult. So this a in Elgamal CryptoSystem, this a is going to be the secret key. And if we have a large prime, then to guess or to find the secret key is going to be difficult. So again, it is a public key crypto system. So that let's say Alice want to send a message to Bob. Alice want to send a message to Bob. So when Alice want to send a message to Bob, Bob needs to generate its public key, and Bob need to send the public key to Alice. So the setup is done by Bob. So how Bob is going to do this setup? How this setup is done by Bob at Bob's end? Choose a large number, large primes. Choose a large prime. Such that large prime, let's say p, such that the discrete log problem is hard in ZP star. Such that discrete log problem in ZP star is hard. So it should be such a large number that discrete log problem in ZP star is hard. And this what is this ZP star? This ZP star is a cyclic group which is equal to ZP minus 0. Now let's say alpha be the generator. Let alpha be the generator of the group let alpha be the generator, choose a secret A, choose a secret A such that 0 to A p minus 2, and then it generates beta which is equal to alpha to the power A mod p. Okay, so the key space of this problem, the key space k is going to be p, alpha, beta and A, and then beta is equal to alpha to the power A mod p. So if we check this key space, this A is going to be the secret key. Rest all P, alpha and beta are public key of Bob. So EB, or you can say EB is the public key of Bob, which is equal to P, alpha, beta. This is public key of Bob. And DB is the secret key or private key of Bob, and this DB is equal to A. It is equal to secret key or private key of Bob. So this is how Bob generates its private and public key. Now because Alice wants to send a message to Bob, Bob will first send its public key to Alice, that is EB, and then using this public key Alice is going to do the encryption, and then using its private key or secret key Bob can do the decryption. So now we will check that how encryption and decryption works in Elgamal CryptoSystem. So now Alice side, Alice is going to do the encryption. So let me write encryption here. Alice is going to do the encryption. Okay. So let's say P plain text space is ZP star. This is the plain text space. Plain text can be any message from ZP star. So this P is plain text space. C is equal to ZP star into ZP star, because it is, we will discuss why we write it, it is ciphertext space. Because in Elgamal CryptoSystem we are going to always generate two ciphertext. So that's why it is ZP star into ZP star. Now it choose a random number K. Now Alice choose a random number K. Choose a random number K such that K belongs to ZP minus 1. This is just an extra bit of secrecy, nothing to do with key. This K is just a masking of plain text or something like that, extra bit of secrecy. It has nothing to do with key. Now the encryption E of EB x comma K. So x is the plain text and K is just a random number. It gives us two ciphertext y1 and y2. So this is Elgamal CryptoSystem. In this CryptoSystem, it is going to give us two ciphertext y1 and y2. That's why the ciphertext space is ZP star into ZP star. So what is the value of y1? Y1 is going to be alpha to the power K mod P, and only Alice known this K, alpha to the power K mod P. And this y2 is going to be x into beta to the power K mod P. This is called masking the plain text. Masking the plain text. So now y1 and then now Alice send y1 and y2 to Bob. So now Alice send y1 and y2, or Alice send the ciphertext C, which is equal to y1 and y2 to Bob. Now next step is done from the Bob side. What is that? That is decryption. So how this decryption is going to work? So this decryption is going to work like D of DB y1 and y2. This DB is the secret key of Bob. And what is the secret key of Bob? The number A. So how decryption works? y2 into y1 to to the power A inverse mod P. And what is this y2? This y2 is, here if you check, the y2 is x dot beta to the power k mod P. So let me write x dot beta to the power k. And what is y1 to the power A? Y1 is alpha k to the power k mod P. So it is like y1 is beta k inverse mod P. y1 to the power A is beta k inverse mod P. So we can write it like this: y1 is equal to alpha k mod P, then y1 to the power A is equal to alpha to the power ka mod P. And what is alpha to the power ka? This is beta to the power k mod P. How we know that alpha to the power k is beta to the power beta is equal to alpha to the power a mod P. So if when we say that alpha to the power k, so it will be beta to the power k mod P. Now if I write y1 to the power a inverse, it is going to be beta to the power k inverse mod P. So if we write it here, beta to the power k inverse mod P, it's going to be 1, and then it is going to be x mod P, which is equal to x. So hence the decryption work in this way. This is how Bob is able to generate the plain text. So this is the encryption and decryption of Elgamal CryptoSystem. So we discussed in this video, Elgamal CryptoSystem, which is based on the discrete log problem, which is discussed in Diffie-Hellman key exchange. So discrete log problem is, let's say we have P, it is a prime number, then ZP star is a cyclic group and ZP star will be ZP minus 0. So then let alpha be a generator. So generator or primitive element of ZP star, and we need to select an A such that beta is congruent to alpha to the power a mod P. So here we need to find the value of A. The value of this A, complexity to the algorithm which finds the value of A depends upon the value of P. As large P we will select, as difficult it will be to find the value of A, and this is called discrete log problem. So in Elgamal CryptoSystem, this A is the secret key. So now we will do the setup. So because Alice want to send a message to Bob, so Alice is going to encrypt it using Bob's public key. So Bob need to run the setup. It will select a prime, large prime, such that the discrete log problem in ZP star is hard, and ZP star we all know it is ZP minus 0. Now alpha be the generator of this ZP star. Choose a secret A such that 0A less than P minus 2. Now this beta is equal to, we select a beta which will be equal to alpha to the power A mod P. Now key space K is P alpha beta A, where only this A is the secret key, rest all is the public key, and beta is equal to alpha to the power A mod P. So now this public key is P alpha beta and private key is only A. Now in the next step we discuss encryption, which is done by Alice. So plain text will be ZP star and cipher text will be ZP space will be ZP star into ZP star. Why it is ZP star into ZP star? Because in Elgamal CryptoSystem we always generate two ciphertext. So choose a random number k such that k belongs to ZP minus 1. This k has nothing to do with the secrecy. It is just an extra bit of it has nothing to do with key. This is just an extra bit of secrecy. It is like masking of plain text. So then E of EB xk, this x is the plain text and k is just this number, gives us y1 and y2. So y1 will be alpha to the power k mod p and y2 will be x dot beta to the power k mod p. Now decryption says y1a inverse mod p. So y2 we know x dot beta to the power k mod p, and what is y1? Alpha to the power k mod p. So when we select y1 to the power, when we compute y1 to the power k, y1 to the power a, it is going to be alpha to the power k mod p, and alpha to the power a mod p is beta, so it is going to be beta to the power k mod p, and y1 to the power a inverse is equal to beta to the power k inverse mod P, and we put the value here and it comes out to be X, which is plain text. So this is how encryption and decryption performed in Elgamal crypto system. Now let's take an example also of this Elgamal crypto system. So example says that we have a prime P which is a large number, and let's say it is 2579, and this is because it is the part of public key. So this is public. Now we need a generator alpha of ZP star or Z2579 star. So alpha is equal to 2. This will also be public. Then we select A and A. Let's say A is equal to 765, and this A is private or secret key of Bob. And then we calculate beta, which is alpha to the power A mod P. So alpha to the power A mod P is 2 to the power 765 mod 2579. So when you calculate, it comes out to be, with modular arithmetic, it comes out to be 949, and it is also public. So now what Alice do? So this is the setup phase. We have a EB, which is the public key, which is alpha, beta and P. Alpha, beta and P. And we have a secret key DB, which is A, and which is equal to 765. Now Alice is going to do the encryption. So encryption will work like X, it need to find a message X, and let's say that for now message is 1299. So and K is equal to 853. This is random chosen by Alice. This is a random number. This is a random number chosen by Alice. So encryption E of EB xk is equal to y1 comma y2. So where y1 is equal to alpha to the power k. What is alpha here? 2, and what is k here? K is selected by Alice, k here 853. So alpha to the power k is 2 to the power 853 mod p, which is 2579. So it comes out to be, when we calculate, it will come out to be 535. Similarly, y2 is equal to x dot beta to the power k mod p. So x is equal to 1299, beta is equal to 949, k is equal to 853 mod 2579. So when we calculate, it comes out to be 2396. So this ciphertext y1 comma y2 is equal to 435 comma 2396. Now how decryption works? So decryption is done by Bob. So for decryption purpose, what y1 is equal to alpha to the power k mod p. So what we have to find out? y1 to the power a, which is alpha to the power ka mod p, and or you can say beta to the power k mod p, because alpha to the power k mod p is beta to the power k. So beta to the power k mod p means beta is 949, k is 853 mod 2579, and y1 A inverse mod 2579 is going to give us x, or the plain text. So y2 is equal to 2396, and y1 to the power a is equal to 435. This comes out to be 435. So it will be 435 inverse mod 257, and when 2571, and when we calculate it comes out to be 1299. All the calculations are done using modular arithmetic rules. So this is how we can verify the using decryption that encryption is for the plain text 1299. So this was an example also how we do the calculations for Elgamal CryptoSystem. So in the next video we are going to discuss about the digital signatures, how these digital signature, what does it mean by digital signature, and how these digital signatures work for RSA and Elgamal CryptoSystem. Thank you.